Okay, for this next problem, we're looking at 2.79. Let me just go ahead and read it. Motorcycle is moving at 30 meters per second when the rider applies the brakes, giving the motorcycle a constant deceleration. During the 3-second interval immediately after braking begins, the speed decreases to 15 meters per second. What distance does a motorcycle travel from the instant braking begins until the motorcycle stops? So it tells us our initial speed is 30 meters per second. It tells us at 3 seconds my speed is 15 meters per second. So from here, just this information, I automatically know that I can use this equation to find my acceleration. So I'm going to go ahead and do that. I haven't really dealt with the problem, but I'm going to do, VF is 15, VI is 30, and T is 3. So my acceleration is -5 meters per second. And this is important that this is negative, because if I were to draw a motion map, if I'm slowing down, then my acceleration vectors are pointing to the left, indicating a negative acceleration. So that's good. Now it wants to know, we know here v equals 30, we know here v equals 15, and we know here v is going to equal 0, and we're trying to find this total displacement. There are a couple ways we can do this. We know the time from here to here is 3 seconds, and we know that if this is constantly accelerating at -5 meters per second, so we're losing 5 meters per second every second. So after one more second, we are at 10 meters per second. After 2 seconds, we're at 5 meters per second. And after 3 seconds, we're at 0 meters per second. So we just found that a total time is 6 seconds. Or you could remember to what we talked about in class, whereas, this instantaneous speed is halfway, let me retry this. The speed here is your average speed, where the speed at your middle point is equal to your average speed. Well, if I take a mathematical average of 0 and 30, it's 15. So I must know that 3 seconds is the halfway time point. So that means my total time would be 6 seconds. So from there, I could say, well, delta x equals 1/2 at squared plus vit, and solve for delta x that way. So 1/2 -5 6 squared plus initial speed of 30. It's positive because we're moving to the right, times 6. If you do that, you get 90 meters. This is -90 plus 180, and 90 meters is correct. Another way to do this is and the way I did this, I just said, well, I don't know my total time, but I'm going to assume that to slow down to 0, I am assuming a constant acceleration. So I'm going to use one of my constant acceleration equations that doesn't deal with time, and solve for delta x that way. So I said my final velocity was 0, initial velocity was 30, my acceleration was -5, and I'm solving for delta x. So this is -30 squared divided by -10 equals delta x, and lo and behold, that's 90 meters as well. So there's 2 different ways to do that problem.